We're now going to go through a practice problem with the IS curve. So you're given this information with all the information that you need to solve this out. And the first part of the question asks for us to derive an expression for the IS curve. And we just created the IS curve equation, which is y equals 1 over 1 minus MPC. And then we have times C bar, I bar, G bar, and X bar. We have minus that MPC times T bar, minus D times F bar, minus, and then we have all of the response variables, C plus D plus X, all over 1 minus MPC, that times R. R is our unknown here. So we just have to plug things in and figure this out. Y equals 1 over 1 minus 0.6 times C bar is 1 plus I bar is 1.3 plus G bar is 3.1 plus NX bar is 1.2 minus MPC is 0.6 times T, which is 3.1, minus D, which is 0.1, times F bar, which is 1.2, minus, and then we've got C bar, or regular C, which is 0.2, D is 0.1, X is 0.3, all over 1 minus 0.6, all of that times R. And this may seem like a lot, right? But you know the equation, and then we just have to plug in. So it's very straightforward arithmetic from here. Notice, right, we're trying to find our IS curve, and remember our IS is y as a function of R, right? So this is where we have y as a function of R. Everything else should be numerical at this point. So we can go ahead and we can start to fill this out with a calculator. So 1 over 0.4, which would be 2.5. On the inside here, what do we have? We have a 1, 2, 3, 4, 5. We have 6 point, 1, 2, 3, 4, 5, 6. We have 6.6 minus 0.6 times 3.1, which is 1.86. And then minus 0.1 times 1.2 would be 0.12. And then over here, we have 0.2 plus 0.1 plus 0.3. That's 1, 2, 3, 4, 5, 6. So that's going to be 0.6 divided by 0.4 times R. We can continue to simplify this by saying 6.6 minus 1.86 minus 0.12 is going to get us to 4.62 minus 0.6 divided by 0.4 is going to give us 1.5 times R. Last thing we need to do is we just need to say y equals 2.5 times 4.62 equals 11.55 minus 1.5 R. This right here is our IS function. That's what we're going to use to calculate the rest of this question. So I'm going to move this up here so we can still see the IS function, because the second part of the question asks us if the Fed sets the real interest rate to equal to 2%, what is going to be the output? What is Y? So as we continue through this lesson, we're going to actually be able to solve this whole model out. But for now, right at this point, we only have the IS curve. Well, all we're going to do is we're just going to plug in 2. So note that 2% in this model, you're just plugging in the whole number 2. So that would be y equals 11.55 minus 1.5 times 2. So y equals 11.55 minus 3. So y will equal to 8.55. And I don't remember if this was in trillions or billions. We can always scroll back up. It was in trillions. So if you want to be real clear with this, although like on an exam, I would take 8.55. 8.55 trillion would be the official answer of what my overall GDP and output would be. So what does that look like on a graph, right? So part 3 says show this on a graph. So if I go ahead and draw the graph over here, I know that it is output versus the real interest rate. I know my IS curve is downward sloping, so make sure you draw that out. And I know that if the interest rate was somewhere here, which was 2%, this point, let's just call this point A, would be associated with $8.55 trillion of GDP. So that's how we would create the IS curve with numbers, and then we would plug something in to figure out what our official point is, our official combination. And then, of course, you could do shifts of it to the right or to the left if any of the variables changed, and that's what you'll get a lot of practice with on your quizzes and your homework and preparing you for the exam.